The objective here is to read GitLab's guidance on getting started with CI/CD. Now, starting from version 8, GitLab's continuous integration, that's what CI is in case you didn't know, GitLab CI is fully integrated into GitLab itself and is enabled by default on all projects. They say you should keep in mind that only project maintainers and admin users have the permissions to access a project's settings. So our first question is, who can access a project's settings? And this is in GitLab. The term maintainers and admin users is the correct term for a person who can do this. And another thing they're trying to tell us to take note of here, if you're coming over to GitLab from Jenkins, you should check out their reference for converting your pre-existing pipelines over to their format. Okay, their real introduction starts with this. If you add a .gitlab -ci YAML file to the root directory of your repository and configure your GitLab project to use a runner, then each commit or push will trigger your CI pipeline. So the question is, what is triggering your CI pipeline? And the answer is every time you commit or push to your repository, but it won't trigger your pipeline if you don't have this YAML file in your root directory. And then we'll talk about configuring a runner a little later down in this article. Now, this YAML file tells the GitLab runner what to do, and by default, it runs a pipeline with 3 stages. You have build, test, and deploy. You don't need to use all 3 stages. If a stage has no jobs, then it's just ignored. Now, if everything runs okay, meaning you're not getting any zeros for your returns, you'll get a nice green check mark associated with the commit. And this makes it easy to see whether a commit caused any of the tests to fail before you even look at the code. Most projects use GitLab CI service to run the test suite so that developers can get immediate feedback if they broke something. Now, there's a growing trend to use continuous delivery and continuous deployment to automatically deploy tested code to staging and production environments. So in brief, the steps needed to have a working CI can be summed up to add your YAML file to the root directory and configure your runner. From there on, every push to your Git repository will get the runner to automatically start the pipeline, and the pipeline will appear under the project's pipelines pages. So to get started here, they want you to make sure you have an instance of the version 8 mentioned above. You'll need a project in GitLab that you would use to use CI in, and then you must be a maintainer or owner, like admin of the project. Okay, so let's assume all of this is true. They want to break down this process into pieces. First, let's create your YAML file. What is this YAML file? It is a file where you configure what CI does with your project. It lives in the root of your repository. They already said that. On any push to your repository, GitLab will look for this YAML file and start jobs on runners according to the contents of the file. So a good question could be, what is GitLab looking at in the file? They're looking for jobs that the runners are going to do. Forks can easily use CI. Branches will have different pipelines and jobs, and you will have a single source of truth for CI. And if you want to know why they've chosen YAML here, you can read about it in their blog. But if we go back to that previous sentence, my question on there is, different branches can contain what? And the answer is the different branches can have different pipelines and different jobs, but you, looking at all of that, will have a single source of truth. One branch is breaking stuff and the other's not. You'll be able to see that. So let's look at a simple YAML file. It has to be named .gitlab-ci.yaml for it to work. And our example here is for Ruby on Rails, so image Ruby :2.5. Before script says that you need to do an apt get update, and you can read the rest right here. Then check the Ruby version. You can also say which Ruby. There's a gem install bundler, a bundle install, and you could just keep going through this simple YAML file. They say this is the simplest possible configuration that will work for most Ruby applications. Here it's defining 2 jobs, RSpec and Rubocop. Just made up names here. So these 2 jobs have different commands to be executed. Before every job, the commands defined by before script are executed. So there's some good information right here in before script that you'd be getting before the jobs. Now this file defines sets of jobs with constraints of how and when they should be run. The jobs defined as top-level elements with a name, in this case, the two arbitrary ones I read. Those two jobs are top-level elements, and they always have to contain the script keyword. So if we go back there, right, it says script on each of them. Jobs are used to create jobs, which are then picked by runners and executed within the environment of the runner. Simply asked, what are runners doing? They are picking jobs and executing them within the environment of themselves, the runner that is. What is important is that each job is run independently from the other. If you want to check whether the YAML file of your project is valid, there is a lint tool under the page, and maybe we should type that out just so you memorize it or have a reference in your notes. So the question is, what page contains a lint tool? And remember, this tool is for checking if your file works. So silly question, but what's the CI Lint button doing? It's checking if your YAML file is working as well. And then they give you a link for more information. Let's read here. Push the YAML file to GitLab. Once you've created the file, you should add it to your Git repository and push it to GitLab. Just type in git add, the name of the file, then git commit, you can add the message that you're adding the file, and push it to your origin master. Now if you go to the pipelines page, you'll see that the pipeline is pending. Now they want you to note, maybe note twice, that if you have a mirrored repository where a GitLab pulls from, you may need to enable pipeline triggering in your project's settings. From settings, go to repository, pull from remote repository, and trigger pipelines for mirror update. So the question is, what do you need to do if using a mirrored repository? You could keep it simple and just say you need to trigger the pipelines for mirror updates. Now you can also go to the commits page and notice the little pause icon next to the commit SHA. So here it is right there, little pause button, and then there's the SHA hash. Clicking on it, you will be directed to the jobs page for that specific commit. So it's pending, number 82 by the administrator. And here this commit is for the master branch. Notice that there is a pending job which is named after what we wrote in the YAML file, the word stuck. Okay, see stuck right there? Stuck indicates that there is no runner configured yet for this job. So what does stuck indicate is my question. The next step is to configure a runner so that it picks the pending jobs. So here's how we configure runners. So for the jobs you've defined in that file, YAML file, a runner can be a virtual machine, a VPS, a bare metal machine, a Docker container, or even a cluster of containers. So I'm just going to say, what can a runner be? The runners communicate through an API so that the only requirement is that the runner's machine has network access to the GitLab server. A runner can be specific to a certain project or serve multiple projects in GitLab. If it serves all the projects, it's called a shared runner. To finish up here though, you can find whether any runners are assigned to your project by going to the settings and then CI/CD. Setting up a runner is easy and straightforward. The official runner supported by GitLab is written in Go, and its documentation can be found here. Now in order to have a functional runner, you need to follow two steps. Install it and then configure it. Follow the links above to set up your runner, or use a shared runner as described in the next section. Once the runner has been set up, you should see it on the runners page of your project following the settings/CI/CD. So left hand side says specific runners, right hand side says shared runners. Let's just look at the specific. Click the button below to begin the install process by navigating to the Kubernetes page, select an existing Kubernetes cluster or create a new one. And then from the Kubernetes cluster details view, install the runner from the application list. If you want to do it manually, you can click there and specify the following URL during the runner setup, and then they'll give you a registration token during the setup. So I think I'll end right here. You can read the shared runners if it applies to you. This is nifty for seeing the status of your pipeline and jobs. Or if you want a different view of it rather than the pipeline, trigger, commit, and stages, you can look at this table where it says the job, then the pipeline it's on, the stage it's in, the name it has, and there's some timing information. Now by clicking on the job status, you'll be able to see the log of that job. This is important for you to diagnose why a job failed or acted differently than you had expected. Now in the next video, I'm going to go over these examples because they are really cool and helpful.